Now let's see a simple example to understand the first step of writing very simple codes, and also see and practice how we can load this code, the written code, to our Arduino. Also, we will see what happens if there is something wrong in the syntax of the code. So the syntax of the code is just simply C programming. Whatever is correct in C is correct here. So you should be familiar with the syntax that we use in the C programming. Also, there are very specific and very important functions for Arduino. For a list of them, I suggest you to take a look at the course material. Also, we have Arduino function, Arduino reference. So just Google Arduino reference functions, and you will find the list of all functions available here. These are the functions, predefined useful functions that we will be using. They are categorized, so we have in different categories, we have different functions. These are very, very, very useful functions. We will be using some of these in this our simple code. But if you're interested to know what this function is, just click. It will give you all the detail of that code, starting from the syntax, parameters, what it will return, and even a very useful example on how you should be using that code. Anyways, let's go back to our code. Here, each Arduino board comes with a default LED, and this default LED is connected to a default pin. In this case, since we are using Arduino Do, this LED is connected to pin 13. So to make it more readable and more human-friendly code, I am defining this pin number 13 here. I define it as LED. So simply I just designate LED to this pin. So from now on, whenever I say LED, the program understands that I am referring to port number 13 on this board, which is on the board, which is connected in this PCB, in this Arduino board, is connected to that LED. Pin mode is a function that can configure your pin as input or output. Here, I want to turn on this LED. So I am actually sending voltage to this LED. That's why I'm configuring this LED pin as output pin, and this is how we do that. This is the configuration part. So you can imagine that these two lines are the lines that I just want to do and then go to my main code. They don't need to be repeated, right? And then in the loop, which as we said, whatever I write here will be repeated in an infinite loop. What I write is digital write LED high. This means I want to write a digital value. A digital value is as voltage 0 or voltage VDD. In this case, it's 3.3 volt. So when I'm saying digital write LED high, this simply means I want this LED pin, which was defined as 13, to apply a high value, which is 3.3 volt, to the outside world. Here, the outside world is the LED, right, which is connected. So it just simply drives this pin high, 3.3 volt. We have a very useful function is delay. If you write delay, your microcontroller will just stay idle. It will not do anything. It will not execute any command. It will just stay there. So we want the microcontroller to stay there for 1,000 milliseconds. So the amount of delay that it creates is 1,000 milliseconds or 1 second. So it will turn the LED on. It will wait for 1 second. Then digital write LED low. It will turn the voltage of that pin low, which is 0, and that will turn off the LED. And then we'll wait for 1 second. And then this part will keep repeating. Now, I want to compile this code and see if there is any syntax error or anything. To do that, we just simply press this here, this verify icon. If you see this message that is in white, it is Sketch uses this many bytes program storage space, blah blah. It means the compiling is successful. So there is no error in terms of syntax, not in terms of functionality. Your code might be correct syntax wise, then you will see this message, but may or may not be correct in terms of its function. Like it might uh, it might be correct and it might do the thing you want the microcontroller to do for you, or it might be wrong. You will not know if it is functionally okay or not at this stage. You will only know if the syntax is okay, and this code can be compiled, converted to machine code, and gets loaded to the microcontroller. So in this case, it's fine. I'm just going to intentionally create a syntax error. Let's just delete this semicolon and then press verify again. Let's see what happens. Oops, yeah. See, so this is important. So it says expected the semicolon before bracket, right? Before closing this bracket, it tells me that the syntax error that it finds is this. So you will see if there is a syntax error, you will see a message in red, and it usually finds the problem and where it happens, and it shows you highlights. So you just go back to your code and see what syntax error you've made. So I'm just going to correct this and compile again. Yes. Okay, now it is successful.